Greetings and salutations, everybody. Today I have kind of a fun little project here. It was a business card out of a PCB. The aim of this business card is to promote an ESD remediation business. It's obviously fake, so don't go looking up any of this information on here. The goal of this circuit, this little guy in the corner here, is to, when you apply a very high 8 kilovolts to 15, 20 kilovolts, I think is what I designed it for, it will generate enough energy to safely illuminate an LED. Now, obviously this is untested. This is the first go around with it. If that should fail, I do have a neon lamp that I can potentially try. To just hook it right up to the end here, and that should be able to generate at the voltage level. So that's the backup plan. My initial plan obviously is to do this, so we're going to go ahead and build this up and test it out. A little pro tip for you when you're doing small little projects like this and you buy your parts, DigiKey allows you to do a customer reference number, and as you can see there, I put D2 right there, which means I can build this board here without having to have the schematic next to me and say, okay, D2 is this part number, and oh, here it is. Enough talking, let's get to it. All right, so there we go. Focus, there we go. All soldered up. We can help. So like I said, plan is to hold it on one of these pads with yourself, or put the grounding lug on here for an ESD projector. Static shock this point. I left this open, exposed, so that way you could potentially hold it at any point on this and try to get the static to dissipate over here, so it can be more of a real world application. For this demo to see, because again, I'm not really sure this is going to work. In fact, I'm almost certain this won't work, but I wanted to try it anyways. I'm actually going to go and get an ESD tester, ESD gun, and shock this so I know exactly what the voltage of the electrostatic discharge is going to be, and so that way I can get the exact points that I want. So we'll do that. I have two in case they break. And again, backup plan is this. No circuitry. I am going to solder some little thin wire, which I don't have on me right at the moment, but you kind of get the picture. I'm going to run this just straight over here, so that way this kind of acts as a little ESD generation point, and then this should just show it. So if that ends up working, this will be a much cheaper circuit. The only problem is it is very fat, as you can see there, so it's not really, doesn't lend itself well to being a card. Fine either way, it's just the front looks sleeker with that LED on there as opposed to a neon little lamp. So let's go ahead and test these two designs here.
We are going to start out with 8 kilovolts and move to 10 kilovolts on the LED version. That first zap was visible at the probe. As you can see, it did not illuminate the LED. If you look closely, you will see the discharge running across the alligator clip instead of the probe on the rest of those attempts. Let's bump to 12 kilovolts and switch to the neon bulb. And look at that, it worked! Here it is again in slow motion. The camera does not do this justice, as the illumination is much more pronounced in person. So, what did we learn? Mainly that harnessing static is difficult due to the extremely high voltage and extremely low current. I thought that maybe there was a passive way to convert the voltage and build current, but as you have seen, my method did not function as intended. I also confirmed that neon bulbs need surprisingly low current to illuminate and can handle large voltages. Until next time, I'm the ill-informed human. Goodbye!